Firstly, I would like to thank all the wonderful staffs in this school. So they help us to make our research and all this kind of thing can be shared effectively. I would report back to you that what my research team is working on. We believe that creation is an act of collaboration. And this is the motivation. We want to build the better analysis tools. Harp-Daal is basically a tool to do a high performance big data analysis. And we want to run it on HPC and cloud. This is a collaboration with the industry and funded by NSF, but most of the work is done by our students and in collaborators from all over the place. If we imagine what will happen in the future is there will be 7.6 billion devices around the world by 2020. And the whole world is centered around the computing capabilities, but the skirt, you can see all these sensors, devices. You can utilize them at home, at work, and in the driving car, and all over the places. So this whole network will be fascinating to make people's life much easier. However, in order to do that, there are some technologies and computing capabilities must be provided. So I have 3 slides. The first one is talking about what kind of a computation has to be supported effectively from the center of data center to the edge and to the desktop computer. So you can see the patterns of this computation for supporting data intensive applications from sequential to placement parallel to MapReduce is the big data paradigm and to the HPC high-end computing using MPI. So we aim to cover the full spectrum of all of them and build the system portable to different kind of computer systems, hardwares. The second level I have to talk about, in order to build the real system, it's critically important to understand the machine learning algorithm itself. So if you look at the whole stack and the classification of the algorithm, at this point of the state of art, people building individual algorithm applications, but it will be imperative for the community to collectively build a much powerful the kernel library, just like linear algebra, which has to be done at the solver level. Finally, I show that the real application, what it involves. This is an example using machine learning clustering algorithm for image data. So you can see that there's a lot of data involved about running the algorithms. You can see the classification of similar type of images together. So there's a very popular tool. It's in Python because it's easy to use. It's called sklearn. And the right-hand side is our framework running the same thing, but in a much scalable way. So to end this up, my talk, and I give you a live demo. So what do? We have the whole stack from the Python to the Harp-Daal framework, utilize Intel's kernel library, but distribute that and package it into a container VM. And then we set it up on the Google Cloud. So you can see that there's a whole demonstration is real-time recording, and put it as a whole running from pre-processing the data, reduced dimension using PCA, and running the training using k-means, and then validate all of this result. So it takes about 30 seconds. And this is the generating the validation of result. So that's the end of my talk. Thank you so much.